Okay, let's go for another one. Oh, what's happening here? Okay. Same thing as always, we'll just kind of like scroll a bit until we land on one. Let's do here. Okay, 3, 6, 7, 4, minimum operations to equalize array. You are given an integer array nums of length n. In one operation, choose any subarray and replace each element in that subarray with the bitwise AND of all elements. Return the minimum number of operations required to make all elements of nums equal. A subarray is a contiguous, non-empty sequence of elements within an array. Okay, example 1, we got an input array nums, elements 1 and 2, and the output, meaning the number of operations, is 1. Explanation here, choose nums at 0 through 1, and then 1 and 2 is 0, so the array becomes 0, 0, and all elements are equal in one operation. Okay, example 2, input nums is 555, output 0, explanation nums is an element with elements nums is an array with elements 555, which already has all elements equal, so 0 operations are required. Kind of tricky just because I'm not too familiar with the bitwise operators, so I need to figure out what that even means. I think this is the most informative piece of text. Can I like mess with the Okay, yeah, I mean, learning lesson, right? What is bitwise and how do you use it? Bitwise and compares two numbers bit by bit and returns a new number. The rule is simple. 1 and 1 is 1, 1 and 0 is okay. So a bit is 1 only if both bits are 1. I see. So it's only 1 ampersand. Okay. So in one operation, choose a subarray and replace each element in that subarray with the bitwise AND of all elements. Return the minimum number of operations required to make all elements of num equal. Return the minimum number of operations required. So in one operation, so I know it says in one operation, kind of implying that you're only supposed to do this once, but then return the minimum number of operations implies that it can be more than one, that it won't always be one. So I think this is just saying, like, in one iteration. I guess my next question is, like, on this assignment where the array becomes 0, 0, I'm doing that, right? Manually, I'm typing in assignment operators, or okay. Okay. In one operation, choose any subarray. I wonder if by in one operation they mean one of these expressions. Okay, well, I mean, let's just start writing something. Left will be 0. N. Oh, it doesn't give us n. Okay. I think I need to go -1 on the right pointer. Maybe make a counter. go start at 0. Could be like a counter of sorts. I might not need it, but let's just see. So I'm thinking, yeah, starting with the widest possible subarray. So we want to do the bitwise AND of all elements. So to do that, we would take maybe for I assign that to the left, and then as long as I is less than the right, oh, actually I don't know if that'll work because of the I'll miss an element, I think. Okay, just kind of going with my instinct here. Okay. Is this a thing? Okay. Bitwise and nums at I. And so then after that, we should have the valid bitwise AND of all elements. And so then we should be able to reassign now. And then we can tick min ops. can do a check for the whole array. We want the first element that way we have something to compare against. That means this can start at 1. If first val is equal to nums at I'm not sure actually if this is going to work. We return the minops. This isn't going to work because we're shortening the window and then we're not really checking if Oh, this one's tricky for me. I mean, if I'm replacing every value with the same bitwise and, wouldn't it necessarily be this was passing at first, so I must have done something. It's that I'm dumb. Okay. Hmm. I don't think this will pass. I'll probably end up calling it here. What? What? I was so not confident with this solution. I feel like this is just a weird question. It's always one, isn't it? Because like if that's the case, I don't even think we need any of this. Yeah, I mean, I don't even know what to say.